Right, let's fix this thing now. So the story so far, this is the bearing that came off of it, which as you can see is loose. It's loose over there, but where it actually sits is here, and this is worn down. I just measured this, and this is about 5 thou out of round. No surprise, because it's just a worn surface. So if it was super critical to maintain this at original diameter, then I'd have to have this flame sprayed or something and then turn this back. But it's not really critical to do that because this is my machine. So, and whatever I do here is going to last the rest of its lifetime anyway. So what I have done is procured this bearing, which is a different size to the original one. As you can see, the original one has a smaller ID, but it's the same OD. It's very slightly thinner, the new one. And that means there's loads of room there. So now what I can do is true this surface up to a much more round surface, get rid of the burrs here, and then I can turn a collar that will fit precisely on whatever that diameter ends up as, and precisely inside the bearing. And then everything will run true. Now the only thing is, I'm not going to skim this entire shaft. There's no point removing more material than I need to. And in any case, there's this thread here which I can't alter. So the collar I make won't slide over this. So I will have to split it. That's okay, because it will be made to the precise diameter first, then split it, then it will go over, and then the bearing will go over that. Should work. And because this is thinner, I'll have to make up a 2mm thick custom washer to go on top of this bearing to maintain original spacings. And what happens is one of the tooth pulleys, this one, goes over this in place. So that will sit down then on that custom washer and be maintained at the original spacing. So that's pretty simple. I'll get this in the lathe, check concentricity around this surface because this is an original untouched surface. This bearing I'm not going to take off. There's nothing wrong with this. There's nothing wrong with this one either. It's just this is worn out. And then I'll go in with a grooving tool to clean up these burrs, and then just very lightly clean up this, and then make a collar to suit. Right, here's the setup. I'm using the 4-jaw so that we can get the concentricity dialed in. Got the tailstock supporting the part with a aluminum plug pushing against it, and I've dialed it in to about a 1/2 thou run out, which I think is about as good as we're gonna get. And I've been checking this up and down. There is some variation too, but there's lots there. And what I ended up doing was clocking it on this bearing, since that's what's actually deciding what the axis is. Get that to the crown. And there's enough drag in the bearing, in the grease and balls and everything, so that the outer race doesn't hold up under the pressure of the needle. And if you can see that, you can see the race is turning, but see, I'm 2 thou there. I'll surely be able to do better than that. Let us monkey with it a bit more. So now I'm about a half a thou there. You know, the bearing is good. Wiggling the race does nothing. But spinning the race, I was surprised to find earlier on, gets us a thou. So given that we've got a thou there, I think if we get the thing within a thou, that's as good as we're going to get. So let's check and see where this is now. Very likely this shaft is not round now anyway. So I'm more inclined to go with that surface than this one, but let's just see what it is. And honestly, I'm kind of splitting hairs. Just getting the wobble out of this thing is going to be a good thing. All right, so we're on the crown there, which is good because that was the crown there. Thou and a half. So thou and a half here, thou here. Basically the axis is as straight as I'm going to get it over this distance, which is the distance that matters. So the next stage is to get a grooving tool, take these high spots off and clean up that surface to minimum cleanup. Or, well, to a whole number, whatever. And I have to take this shoulder back to this, just to make sure that nothing I do here hangs the bearing up. So, and this shoulder can go past the top of this sleeve a little bit, that'll be okay. But we want to make sure that the bearing sits up against this surface when assembled. So, I think that's as good as we're going to get it. I think cleaning this up now, making a sleeve and getting the bearing on, the new bearing on there nice and snug will work wonders. I did think about turning this, making an oversized sleeve, kind of clamping it on there and then turning the OD. I think this method is as good as any. Perfect. Well, that should do it. Whatever dimension that is what we'll work to. We'll measure that when we get it off. See, straight in, no problem. It's 1 inch drill. Pretty good initial pass. Now this measurement will not be good enough for finished dimension. This is just to see where we're at. This is 1.2. Now I'm not going full depth. I don't want to remove any more material from under the jaws. So that gives us roughly 56 thou left to take off. This is now getting warm, so I'm going to cool it off. And while that cools off, find a more accurate measurement device. Ah. .355 or 6 actually, 1.3556. So I've actually nailed it. I'm within 4/10 of nominal. And if I do a spring cut, it will go over. Ain't bad, is it? Let's just feel that through. Yeah. It feels pretty even throughout. So with air on that. So that was fun. Now for the OD. Much the same. Got 0 there. For 1.574, so I'm going to take this in 25 to around 1.6. And we're actually 1.602. No, 1.6026. 6026, yep, alright. I'm following the practice of making sure that I take the same depth of cut, having set the DRO, so that I don't change anything in the machining process, and that way I have the best chance of hitting dimension. Okay. That for a bit. I didn't necessarily make cuts with coolant running just so that I could see what was going on, but I then use coolant to make sure that the part is not hot, because at these sensitive dimensions that could change my reading and throw my final dimension off. Okay. 1.575 plus 10, 1.585. Right on, which is exactly where I had it set. So, I'm deliberately covering up the numbers because I don't want to influence my measurement. I'm going purely on feel. I think that's it. $575 less 1, so it's 574. 1.5746. So we're actually 6/10. So we'll do it. We'll just run the same again. Yeah, pretty easy. We're very sensitive again. So I'll run the same. Second line, Steve, Popular wisdom says you can't do that with carbide inserts, what I just did. We're now 5744. That took 4/10 off, best as I can measure. work. But you can't use carbide inserts to do tiny cuts, so they tell me. I don't let it stop me. Oh, that says 1.5743. Very likely at these very fine cuts, I'm really just rubbing the surface off rather than cutting it. Still hit dimension though. Oh, magic, isn't it? Magic. You can keep your bloody hobby lathes. Now 1.57. .38. There we go. That's what I wanted. So we're now -4/10 on our nominal. I think what we'll do, at this juncture, generous chamfer. So I'm going to pull that good. You want to cut off? 14 millimeter. Okay. There we go. See what's down it. And just any. That's very light. Oh, yeah. That's our dead one. Now, I need to split, so I can do that. Right. So I think the sequence is going to be, because this is pressed into the plate from underneath, and I think this will have to go on here first, and then we'll press this into the plate once I've cleaned the plate up, and then the new bearing will go in from the top. So with that, this has to go on here, and this might be a bit fiddly. In fact, what might... Right. Next thing to do is finish cleaning up this plate, which I'll do off camera. Hammering bearings into a housing is never a good idea. It's always better to press them in if you can. And as you've seen, I don't have access to a shop press. So I've lashed together this setup where I've got two G-clamps held in the vise with a steel plate as a base. And now what I can do is hold the shaft with the lower bearing on here and put this plate over the top and press it down onto the bearing, and I think that's a pretty good approach.
How about new?
Yeah, perhaps you're right. So I went and got one of these shop presses like everybody's got. This will be a nicer way of pressing this in. So let's just do it. Lovely. And now the brand new bearing. Here's the new bearing, which, as you can see, has a ID that's much bigger than the original shaft, that is carefully matched to the new collar. To push it in, I machined up this piece of scraptonium, or it might be stuff-alloy, don't know, but I've machined a through hole that will clear the shaft, and this face, so this is a bit smaller than the ID of the housing and a bit bigger than the ID of the bearing, so as to apply even pressure on the bearing as I insert it. And now we just need a spacer to go on top of that. That's better. It was a little bit cockeyed first time and I didn't have the bearing all the way in. That's what I get for making a really good setup and then half-arsing it part way. But now we're properly in. The bearing is seated below the surface, but I expected that because I knew this bearing was 2 millimeters shorter than the original. And I'll just make a washer to make up that difference. But that spins beautifully. So that collar has taken up the space between the cleaned up shaft and the new bearing. And now there is absolutely no play. And that's going to spin true. So very happy with that. Right, now for the wrong way to do this. Okay, so I say that was the wrong way, but that actually went pretty smoothly, eh? Well, that went well, didn't it? Let's just finger tighten these. Should we give it a try? Way! I'll go the other way so the oil doesn't all spill out. Totally fine coming this way. Oh, it's alright this way now. Okay, don't know what that was about. I think it was just the nuts making it bind up. Alright, that all works. Glory be. Now you can start to see the culmination of some of my efforts. There's the repaired gear, nicely in place. And here's the rest of the head assembly, spindle all in. And now it's time to put the housing and drive shaft over this. So we'll just maybe we'll push this bearing back in first. Explains why the collar didn't come out. All right. And I just went out to the press again, and I discovered that I'd actually pushed the bottom bearing back out because I didn't properly support it. One of the problems with making these videos is that I'm focusing too much on the video and not enough on the job at hand. Anyway, so I've got this assembled properly now. And it's ready to install. You can see the repaired Tufnell gear there. And I've just oiled it up. I'm going to put a little bit of oil on the drive gear as well. Just to get it ready. There we are. There. And this goes right about there. And this is the oiler, and what happens is you put oil in through this tube, it lands on that Tufnell gear and gets spun out, lubricates the shaft. So with that, that's it for this video. That's a very successful repair. I'm very happy with it. I'm not going to show you making the washer because it's literally just a 2mm thick washer to take up space between this pulley and that, so that this pulley sits down firmly. So with that, we'll call it a day. I hope you enjoyed this. Please feel free to leave a comment. I've made this video a little longer than I normally do to show the details more thoroughly. If you have a feeling about that one way or the other, please leave a comment on it. But I hope this was informative or enjoyable or whatever. Do appreciate you all following along. Appreciate very much all my subscribers, and especially the ones that reach out to me with positive comments. Thanks again for looking in. All the very best. And may your surface finishes be chatter-free and your dimensions always in tolerance. Be seeing you.